Yeah, thank you for confirming. So today we are going to talk about blockchain application in cybersecurity, data integrity, e-governance, and contract enforcement mechanisms. Okay. So to begin with, the first topic, as I said, was blockchain in cybersecurity. So blockchain offers a different path towards, security. One, we can say that which is less traveled or maybe nearly new to the cyber criminals, because this is like still evolving technology. So that is the reason this is like less known to everyone, and still researches and everything is going on in terms of how we can achieve more security in blockchain. But we'll still try to see what has been done till now. Okay, so briefly setting up the context of what is cybersecurity. Uh, Again, a practice of defending computers, servers, mobile devices, networks, and data from malicious attacks. So it is what we called as electronic information security. So it involves a lot of aspects. So it's not just data security, it talks about network security. Nobody should be able to intrude into the network and put some malicious things inside and hamper your system and everything. Application security, again, keeping software and devices free of threats. So your application data and everything should not be compromised at any stage. Okay, information security involves integrity and privacy of your data, and that involves like your data storage as well as data transmission. So during transmission also there are possibilities that people can attack and modify or hamper the data. Also the people can attack storage as well. So information security is one critical aspect. Operational security includes processes and decisions for handling and protecting data assets. So permissions, user permissions, access, all those things involve operational security. Disaster recovery and business continuity is again how you respond to the cyber security incidents. So what actions are planned? So usually in larger organizations you will find that these business continuity plans are already defined, and for every project there are separate business continuity plan depending on what kind of applications we are working on. End user as education. End user education is anyone can accidentally introduce a virus, right? People are not used to you these days. You will find that even on WhatsApp, people send you malicious things, and you people who are not used to these kind of things will download it, try to see what it is, and then they are in a fix. So end user education is another aspect of cyber security. So what are basically cyber attacks? So there are different types of cyber attacks that can happen. One is malware, web application attack, credential stuffing, DDoS attack, man in the middle attack, and ransomware attack. So what are these cyber attacks basically? So malware is a malicious software. So that might comprise of organizations data, or damaging the information system. So for example, hackers use phishing campaigns to induce user to click on certain links or attachments, and then when you click on those links and attachment, that installs a malware on your system, and that starts hampering your system. So that we call as malware. Web application attack or credentials stuffing. So this is like initial step in mining, where user data in a web application is attacked. The data obtained can be like part of brute force attack that uses stolen credentials to gain access to the user accounts. DDoS attack is like distributed denial of service. So, primary this attack usually will find in large organizations. So, what it does is it sends a stream of data traffic to a targeted site with intent to overload or disrupt your systems. So it can be disrupting your system temporarily or even permanently as well. So that is DDoS attack. Man in the middle attack, we call it as MITM. So it's like it involves an unauthorized actor, positioning its access in transmission in between user and the uh, whatever application or a trusted party with which the data is being transmitted, right? They'll try to intercept it. That is called man in the middle attack. And then the ransomware attack. So ideally, these are the different types of cyber attacks that can happen, and possible blockchain use cases where we can try to address some of these is say for firstly is IoT security. So as I said, most of the industrial applications we saw yesterday, it's a combination of IoT and blockchain that are being used for end-to-end automation. So security of IoT uh, appliances or IoT applications is very essential. Okay. uh, so the security of data and system from hackers has always been a major concern. So usage of blockchain is going to help you use different types of encryptions and secure communications and channels, key management techniques, and authentication. Okay, so that is the way you are going to secure your IoT applications. The integrity of software downloads, again, blockchain can be utilized to verify updates and installers to prevent malicious software from infecting the devices. So here what basically is getting used is hashes. Hashes are recorded in the blockchain, and new software identities can be compared to hashes to verify the integrity. Data transmission protection, again, encryption technologies are playing a key role here. Whatever data is being transmitted, it should be transmitted in encrypted format so that nobody can gain the access for it. Decentralized storage for critical data. So blockchain based storage, as I said, it can store a small amount of data, but it has its own file system as well, where we can which can be used, and which has encryption technologies inbuilt, which can be used to store large amount of data as well. And then mitigating the DDoS attacks. So uh, this attack, as we discussed, where hackers aim to generate a flood of internet traffic and disrupt the flow. So the properties of immutability means you cannot modify any information straight away in blockchain, and plus cryptography. These are the features that can answer or try to mitigate the DDoS attacks. DNS security is another important aspect. So DNS is kind of public directory for IP addresses, as we all know. Hackers have tried to access the DNS and exploit the links and crashing the sites. So again, immutability and decentralized systems. These are the properties by which we can try to mitigate these kinds of cybersecurity attacks. So these are the possible use cases of blockchain for cybersecurity. But even if I say that these are the features by which we can answer cybersecurity threats, there are certain areas wherein the conventional systems and the blockchain system both can be attacked. So only the way they will be attacked is different, but still they can be attacked. So if you can see this, so both traditional computing and blockchain have some security considerations. Okay, so for example, denial of service. So in traditional environments, usually people target the web servers and prevent customer from accessing the company services. Okay, so what they do is they try to make connection request to the server, and once they get access, they try to attack your web applications which are providing some company services. So conventionally, this is what happens. In blockchain, what happens is the denial of service attack involves submitting more transactions to the blockchain that it can handle. So, since many blockchains have fixed size blocks created at a fixed rate and are stored in distributed fashion, the maximum capacity is reached, and then once it exceeds, the blockchain becomes unusable. So the ways are different. Similarly, on endpoint security as well, you will find that the way the conventional and uh, blockchain systems are attacked is different, but it still is prone to gain, to cyber security threats. So it's not like blockchain is foolproof. You will still have ways to attack the blockchain data, or making blockchain unusable. All those things are even possible in blockchain as well. Okay. So, but still, as I said, there are benefits of blockchain, which there are some specific features of blockchain which try to answer this cyber security threats. So just trying to highlight those. The principal advantage of blockchain is distributed ledger. So a dispersed publicly infrastructure model reduces many risks associated with centrally stored data by eliminating most obvious targets. So because it is decentralized, right, the information is scattered across different blocks. So it's practically, because it is a distributed ledger, there are no blocks which are like most obvious targets or as such. And transactions are recorded across every node in the network, making it difficult for attackers to steal, compromise, or tamper the data. Okay. Another traditional weakness is eliminated to blockchain was consensus algorithm. So amendment to any block, that's not possible. Amending the historical transactions, it's not that easy, because you cannot, you have to take the consensus of other nodes, and that is when you can modify it. But otherwise, altering the historical records is not that easy. Now, one more important feature that we talked about as well was encryption. So public key, private keys, all that combination, that forms your digital signature, and then this blockchain can shield connected, IoT devices as well, by using these encryption technologies. And then, as we saw, the prevention of DNS and DDoS attacks is also possible, because there is no single point of failure in blockchain. It's a distributed system. So these are the basically features which try to answer the cyber security threats. There are certain challenges, as we saw earlier, when we compared the traditional blockchain threats and the blockchain based system threats. So ways are different. So as we see the challenges, data privacy in public blockchain, anyone can see your transaction. So if after that you decide, okay, let me move on to a private blockchain, you can move, but then your transactions will be secured, but then you won't be able to connect with other public blockchains in the same network. Scalability, as we have seen that it can be a constraint due to block size, or the response time, and the way you have designed the blockchain parameters and all those stuff, that play a important role here for scalability. And then your computing storage resources also, uh, they you require a high computing machine to initiate all this system in place. So scalability is another constraint here. Regulations, I think, they are different everywhere. Even our government, what it allows, so this is decentralized, so still our government bodies are reluctant to move to this. So there are different regulations. They're still trying to understand what is the blockchain structure and complexity, and how we can fit it. And interoperability, I think blockchain platforms use varied ecosystem of their smart contract logic, transaction schemes, and consensus model. So that kind of involves challenges. And but there are certain mitigation methods to it, like we can use some open source things as well to avoid the interoperability challenge, but still it is there. Okay, so with these challenges there are some technological risk as well. So key management encryption technologies that we talked about, if you don't have sufficient skill set to uh, define the highly efficient encryption methodologies, your data is at risk. And once your data is at risk, it's like everything is gone. So this technology, encryption technology, understanding it, defining it, designing it efficiently is important. Okay, unintended fork and chain split attacks. So during the smart contract updated process, there is a chance that some nodes may not support the changes, okay, made during consent. That can lead to new chain split from old and introduce blockchain specific risks such as replay, double spend, etc. So this is one another technological risk wherein, if the consensus is not approving any change, the blockchain might just get split. So then it is again prone to attacks. Inadequate encryption scheme selection. We talked about this earlier as well. So if you are selecting a wrong encryption methodology, SHA 256. So when to apply which technology is also important. So you have to define it based on what data you have, what kind of application it is, what kind of transaction you are involving, and then probably try to introduce and define the encryption methodology. And API integrations, whether it is private or public, third parties will require this API integration, and then that might just involve some trust issues as well. So these are some of the technological risks that we see in implementing cybersecurity across the organizations. But still then we will try to see like how one more possibility, like one more possible use case, how it can be implemented in blockchain. So I believe you all know two factor authentication. Usually the two factor authentication is everywhere in place right now. So once you log in into your system, it again asks you for, it calls your mobile number and asks you for some pin. And once you provide a proper pin, then only you gain access to the application. So we'll try to see how we implement this kind of additional security layer through blockchain. So as I said, two-factor authentication is an extra layer of security used to ensure legitimate owner can only access the account. So by design, we all know blockchain is decentralized technology, and it can allow transaction of any kind, and multiple participants can participate without any intermediaries. So user devices will be authenticated by a third party two factor authentication provider through blockchain network. So as you can see here, there is a third party provider for two factor authentication, and user devices are getting authenticated through the third party provider through blockchain network. So each party in blockchain network will hold endpoint information securely and will activate two factor authentication system to generate the second level of password. Okay, so basically what we use is, again, I'm taking just as an example, Ethereum allows an application to be programmed with smart contracts. So smart using smart contracts, how you can achieve this? A user can say probably he is accessing a web portal and enters his credentials. The web application will then communicate to the blockchain based repository, and that will generate OTP, and then that OTP is shared to user. Okay, and once that OTP is shared, you have to enter it and gain access to the web application. Basically, if you drill down again this architecture, so this is the kind of implementation that you will see. React.js and all those things are part of web application the technologies, And then there is a smart contract and blockchain based storage, wherein through which we are generating the pin for two factor authentication. So this is an overall architecture of how you can implement the additional layer of security for your data on blockchain. So one possible use case. So this is what we have covered. So overall, in terms of cyber security, it's still evolving. Research are going on how better we can do that in blockchain. There are certain challenges in ways blockchain based systems can also be compromised or attacked, but still, I mean, there are certain inbuilt feature of blockchain because it is decentralized, because we have encryption technologies defined, because we have consensus mechanisms, because we have smart contracts. So all these features help us to have a secure system built in, provided you have that kind of skill set and efficient knowledge to define the encryption technologies and consensus mechanisms and contract development as well. So if you have those skill sets in place and if you design it efficiently, your the system can be secure in blockchain. Okay. So moving on, let's talk about data integrity. So data integrity, so basically, as we have seen, the main feature of blockchain is data is immutable, you cannot change it easily, and then that is how you can achieve data integrity in blockchain. But we are going to see a broader perspective, because blockchain can be used in industrial aspects as well, in supply chains as well. So we need to understand what kind of data integrity and is expected in those large systems. So as we can see here, the term data integrity is used here in broader sense in supply chain world, referring not only to the resistance or to unintended data modification, but also to the completeness, timeliness, and accuracy of the data. So as we saw one supply chain example yesterday, right? The rice is one kind of product, or maybe some XYZ product is there. So that product information somebody is going to put in blockchain system, right? So how accurate it is, how we can verify, because there is no way blockchain can self verify or validate that information. So some or the other way, this data integrity also refers to the accuracy or completeness of the data. If somebody is trying to omit certain data and then put it into blockchain system, then also data integrity is violated. So we'll try to see those aspects as well. So this, I think I already mentioned that blockchains are inherently resistant to modification of data. So data is immutable, it cannot be edited, deleted that easily. But then we have to think on the broader aspects as well. Okay, and then organizations are facing audit and regulatory compliance requirement, legal challenges. So that requires us to think about a more broader aspect of what kind of information is being put and how true it is. Okay, so there are three aspects to data integrity requirements for blockchain. So one is data origin integrity, Oracle integrity, and digital twin integrity. So in order to guarantee data integrity, the accuracy and reliability of data must be preserved from the point of creation to the point of usage. Correct? Once that particular product information is inserted and till the time that product is delivered or the transaction is complete, that information has to remain the same. And at first point when it is created, it should be accurate and you know real time enough, and should remain as it is throughout the transaction. So that we refer as data origin integrity. Oracle integrity is like a common step where problems can occur is point of submission to the blockchains. So as I told you, blockchain, there is no way it can self verify or validate whether whatever information is being put is true or not. So what blockchain is can do is it is relying on third party to submit this information, which this particular real time information we refer as oracles. Okay, so in either cases, we can say that oracles are trusted, but depending on the environments or the solution that we are operating in, uh, we have to take care that and ensure that oracles are not modifying or omitting any data before submission. So that we call as oracle integrity. And digital twin integrity is, say, the example that I've taken, right? Product, any XYZ product is a real time product, real world object. And in blockchain, what you do is you provide a digital interpretation of that particular product. So, uh, you represent a real world object as a token basically in the digital form or the blockchain. So it's basically a digital twin. So that digital representation of real world object is what we refer as digital twin. So what is the idea, basic idea behind this digital twin? Is the idea is that whatever useful real world data about that object, right, be it identity, location, origin, all those things can be attached to this digital twin. And once you attach all these information, you can build a lot of useful insights out of this. And if it is true to real world, then definitely it is going to give a different aspect. So the concern here is whether the data attached to the digital twin present is accurate, timely view of physical object and timely view of whether the link between the physical object and digital twin have been compromised. So that we refer as a digital twin integrity. So these are the three different types of data integrities for blockchain which we have to address and see whether we can address it or not. After, so this is all about the data which is present on the blockchain. What about the data which is not present on the blockchain? It is present off the chain, like the file system or somewhere. So we already know, right, the interplanetary file system is there. So what about that? So the on-chain hashes of the data can help a blockchain to refer the off-chain data as needed. So what we do is basically IPFS offers you hash for each file that you store on it. So using the on-chain and off-chain hashes, you can try to match the hash and then access the data. So this arrangement guarantees the unwanted modification to the data and will not go undetected. Okay, so the same problems and considerations and solutions relevant to data integrity will still apply here. The data must be validated in some way, and smart contracts cannot do this directly. So validation needs to be completed by different components, or maybe whosoever is participating in that entire transaction, someone has to validate the information on the files of IPFS. So, where should one look for potential data integrity violations? So, in blockchain, while you develop the blockchain, there are different stages wherein these violations can occur. So, while creating or cleaning, while in storage gateway or oracles, we already saw, and then the node network, exact node network. So, we'll see at each phase what can happen. So while creation and cleaning, so say for example some measurements are made and some raw data is produced. It can be in form of numbers, images, anything. So when it is inputted manually by humans, right, or maybe collected automatically by some devices, the data is cleaned and made useful. Okay, that standardization has to be established, but all these things are being done by human. So there is always a human or organization involved in doing this kind of data cleaning, data analysis and all this stuff. So this is where We can see some integrity might be violated. You feel that some information is unnecessary and you omit it, but you might not know that the information is necessary. So storage gateway, the data, the location where the data is stored. Okay, so data may or may not be stored by same entity that produced it. So there can be some mismatch there. Okay, so there also you can see that some kind of integrity can be violated. And then the APIs or the websites which are referring to that storage gateway, that can also be compromised at some point in time. So that is where you can see some integrity might be violated. So Oracle, the Oracle connects the data gateway to the blockchain. So again, an Oracle will often listen to the data request from blockchain network and relay this request to the data gateway. So, for example, a shipping carrier system may serve as an active role as an Oracle in a blockchain solution, listening for requests for shipping updates and responding accordingly. So this is where you can see that some information can be, modified or omitted, or probably the truthfulness of information can be compromised. And blockchain node network, so the transaction undergoes the consensus process, but the data stored in a variable or some smart contract or blockchain can be usefully consumed and referenced by other smart contracts as well. So that is where we can see that integrity violation might just occur. So what can go wrong at each stage? So say for example, in creation cleaning, a flawed measurement or a flawed analysis, data cleaning process, lack of quality authentication, that might just create integrity violation. At storage, probably a database is not backed up or gets corrupted. In terms of Oracle, the service is down, or probably the data written by data sources in some different format. And in terms of blockchain node network, probably uh, the transaction is not getting completed. There is insufficient fund or support for participants. So all these are different kind of integrity violation that can occur at these stages. Even the physical tampering of, your IoT hardware, or the entire environment might just create some violations. Okay, so data collected, and the object for which it is collected, there is a mismatch, then again it's an integrity violation. Database modifications, deletions prior to transmission can create, storage data violations there, and hackers can abuse it basically. So I think we already saw on storage part the DDoS attack and the man in the middle attack. So they can create data integrity violations. Okay. And blockchain node network, I think we already saw participants in the blockchain consensus mechanism collude to do a rollback in which they censor the transactions or rewrite the blockchain history to reflect a different outcome. So this way also data integrity can be violated. So, what are the solutions for this data integrity in blockchain context? So, there are some traditional principles and techniques around data integrity that we can employ. So, one is proper system design, maintenance, management, quality. That all we can try and see that we can establish it, and then only we put that information in the blockchain. But there are some other advanced mechanisms as well that you might have to put in place to avoid this data integrity violations. So what are those advanced techniques? One is financial rewards. So financial rewards or enhanced privileges awarded to highly reputable actors should be introduced only with great caution. Again, there is a caution here, because as you increase the incentive for potential adversaries, they try to unfairly take advantage of that system. Okay, so this is one way of making sure people are honest enough while they're putting information or doing some quality analysis, but then they should not take undue advantage as well. Automation is another approach wherein you avoid human errors and make sure that the truck. So, for example, whatever shipments are there, right? The vehicle should auto report the location at all times. So drivers don't have an opportunity to lie where they are. So that kind of automation, end-to-end automation, can always help you in avoiding this data integrity violations. Okay. Depending on the severity of faults, whether it was accidental or motivated, and other actor, offending parties can be reprimanded accordingly by marking down their reputation or suspending or revoking their access. Or there are another ways as well where you can try to make sure that people who are trying to do such kind of violations, you stop it. Okay. Cross validation is each input submitted is validated against the nearby inputs. Say for example, if temperature sensors are deployed uh, across the food storage facility, and they report the current temperature around 5 degree, and a single sensor is reporting 30 degree, so possibility that that sensor is malfunctioning, or probably some input is automatically thrown out. So this kind of cross validation, validating against nearest information, can also help you avoid the integrity violations. Ensuring digital twin integrity, I think accuracy and timeliness, and this can only, I mean, nobody should be able to distort the information, and it should be accurate. So this is something probably depends on your quality data analysis, what you are doing, and then how you are putting that information. So basically there can be some kind of checkbox or a questionnaire that you can ask yourself, or probably the people who are designing that system, to ensure we are addressing the security concerns or the integrity concerns here. So I'm just giving you a sample few questions here. Like at every stage, the data is being examined or not. Are we determining what kind of faults may occur? Do we have a proper design maintenance management mechanism? Do we have a proper business continuity plan defined? Or what are the measures to protect the integrity of data? Is the organization considering all the techniques and solution available? In is the quantity and quality of protection achievable? Do we have the right resources? All these are how we will keep the data up to date. To what degree does a use case require assurance of cyber physical correspondence? So all these questions, probably you have to keep a list of this, checklist of this, so that you can ask yourself and try to avoid these integrity violations. Having strict procedures, legal measures as well at sometimes are required to address such kind of thing if there is any dispute in terms of duties, or whatever information people are assigned to make sure they are ensuring the quality. If they are not doing so, there are some legal measures also that you have to think of. Okay. And then which what part of data pipeline can be automated, what can be automated. Mm, what can you do to avoid human errors? What are the mechanisms by which you can detect the fraudulent data? Can you apply some machine learning models detecting anomalies in the data? So all these questions you have to ask yourself or the teams, and make sure you're following it and you have answer for these, so that your blockchain system is secure and it is not violating any data integrity. Okay. Moving on the e-governance part, I think we yesterday we touched based on the banking and financial services. We touched base the healthcare, industrial area sector, supply chains, and all those stuff. There is one more area where blockchain can be utilized, but again, it is not that easy. So e-governance as in government functionaries. So real estate, voting, taxes, healthcare and banking we saw yesterday. So I'm not touching it again. But real estate or maybe voting, taxes, these are the areas which can be, explored on how we can apply blockchain here. So every land and property is, there are a lot of paper documentations that we do, and it's a administrative load. You have to visit lot of offices, lot of different people, and make sure your documentation is up to date. Now in this entire journey, your documentations can be tampered, and it usually happens. So as we know, blockchain will provide you a distributed system, and you can store your land registration records permanently, so that nobody can tamper it and say that no, 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 this land belongs to me. So all that kind of thing we can do. And then again, we all know that when you buy a land, there are a lot of things, lot of different offices, tax department, that you need to visit and do this documentation, registry, and all those stuff. So there won't be any intermediary as such, because again, all these actors will be participants in the blockchain, and you can do it easily. And as we know that it is immutable, so you can stop the property frauds that happen. And then any government action or financial transaction is completely transparent on the blockchain. So it does have its application in the real estate field as well. Voting, I think, is most researched right now for blockchain, because nobody trusts the voting system that we have in place. Even with e-ballots and all those stuffs, we still feel that it's not that transparent. So the voting system implemented in blockchain is very robust and trustworthy, as they say. And no, so for example, in traditional voting system, the final result is declared after 24 hours. But in blockchain based, it will be real time. The results will be as transparent and real time. So you need not wait for 24 hours as well. So in current traditional system, you see you have a voter ID card, and your whereas in blockchain you will have your own digital identity. So you will have to send only single transaction for voting specific thing in the blockchain network. So there won't be any, security threat that someone else is voting in from your account or something like that. Okay, so whosoever is receiving the maximum transactions will be the winner. As simple as that. So that is the reason blockchain is mostly getting researched for, and trying to see if we can implement a transparent voting mechanism. Tax again involves lot of documentation, and uh, there are a lot of offices and authorities, and they have to struggle a lot. So that is the reason blockchain is again getting you know uh, researched on how we can improvise the tax mechanism, and simplify the administrative workload for the government authorities. Okay, so because the transactions are as transparent in blockchain, people are trying to see if we can establish some kind of system for taxes. So with this e-governance thing, let's try and see one, small use case for blockchain, how it is implemented. So usually if you are say you're a supplier of some tool, right, and you're supplying those tools to some government authorities. So usually, say for example, there will be a bidding process for it, where there will be a tender, and there are say 10 distributors who can sell the same product to government. So what they'll do is they will open up a tender, they will list whatever products they want, and they will ask all the distributors to quote their price for the same XYZ tool. So what happens is all distributors will quote their price, and then there will be a specific time assigned to it, wherein you will be able to, one distributor can see the prices quoted by other distributors. So the lowest two or three distributor prices are taken, and then they try to compete who can offer you the same goods at the lowest prices, and whosoever offers it after in that specific time duration, right, whosoever is offering the lowest price, he gets that bid, he wins that tender. So that is the usually process that you follow in when you are selling something to government, or when you're supplying something to government offices. So we'll try to see how we can implement that tender process in the blockchain. So what happens is, usually any company or department will prepare the tender document, right? So first what they will do is, they'll request to the network of nodes to validate the tender document for publish. Okay, and once that verification, validation, consensus, everything is done, a new block is added with the existing blockchain. Okay, and now the tender is ready to publish. So once that tender is validated, verified, that tender is published and a block is added. Now the next process is pre-bid conference or queries or any clarifications that the participants might need. Okay, so queries, clarifications are received in the in some call or meeting or email as well, or there may be some digitized portals as well where you can receive some queries or clarifications. So then you have to again send those clarifications, or maybe if there is some change, you have to send those amendment. Again, it will be verification, validation process will be there, and once after the consensus, the new block will be added, and the clarifications and amendments will be available for the bidders. Now what next? The next step would be to submit the bid. So bidders will prepare again some document based on which they'll quote their prices, right? They will have their own digital signature so that the bidder is authenticated. He submits the bid to the network, and again proof of work and validation process, verification process will happen. And then again, once that verification, validation process is passed, that bid will be added, a block will be added, and bid will be submitted in the system. What happens next is opening of the tender and bid evaluation, and then the award of contract. So as I said, the tender is opened for a specific time. That is where the bids are evaluated, lowest three or lowest five are taken, and then they compete. They try to reduce their prices, and one who has the lowest price wins the contract. So what they do is request the network of node to open the tender. Bid evaluation and award of contract process executed on the centralized server. And then the network of nodes validate the tender, open request, date, time frame, and other constraints are defined, and the tender is approved to tender open request. Again, there is a verification, validation process, and based on the bids that they have received, they will try it will be evaluated as to whom the contract should be avoided. And then the nodes again validate whether that the node to which the contract is avoided is valid or not, and then the contract is awarded. So basically, using smart contracts, we are trying to basically automate the entire tender process. And then there is so much of transparency everywhere that everyone is able to see and understand what is going on, why a certain party is awarded that contract and all. So this is the way in which roughly we can try to implement the tender process in the blockchain. Okay, so with this simple sample e-governance example, I will move on to the enforcement. So enforcement mechanism. So we all know smart contract is an essential element of blockchain. What is that smart contract? It's a piece of code basically wherein you write some if else conditions and some rules and regulation in that smart contract. So how you can enforce it? Because usually traditionally we do have our legal process, or some rules and regulations defined, and we follow it. And if we don't follow it, there are some legal complications. We have to go to the court and justify what we have done. If the court agrees, well and good. If they disagree, you get some punishment out of it. So all these things are present in the traditional system. But same thing how we can have in blockchain is something we are trying to see how we can enforce the smart contracts basically. So for example, in some cases buyers may refuse to make payments after the delivery. Now we are afraid because the product is delivered and we are not getting our money, and parties are not agreeing to that particular agreement. So in traditional mechanism, the legal enforcement will be there, and you will be going to the consumer court and tell that okay, this is what has happened, and then it involves your lawyer cost as well, and the judicial cost as well. So to run this entire mechanism in decentralized manner, parties can alternative rely on long-term relationships, and parties can reward honest behavior with future payoffs and all. So these are some small mechanisms that you can employ in the blockchain system. So you can try to reward the honest people or give some offs to them. That way you can establish the trust relationship, but we'll still try to see what other enforcement mechanisms we can apply. So what is the difference between text based contracts and the digital contracts that we define? Okay, confidentiality, text based contracts are good. I mean, you do it on a stamp paper or something, so they're good. But with smart contracts, it's stored on a closed ledger, and that's how the confidentiality is more on smart contracts. Okay, readability part, it's text based contracts are easy to understand because you can read it, the language is readable. But smart contracts are difficult because again, it's a programming language, so at times it is very difficult to understand what kind of contractual obligations are defined in smart contract. Okay, so there are basic differences in between text based and smart based contracts on different aspects, like readability, execution, third party intermediation. So all these things, there are some differences. So let's try and understand what is smart contract, what are the basic objects, and then probably we'll try to see how we can enforce them. So every smart contract, as we see here, has three basic elements, and we call those are objects. So what are those? The signatories, the subject of the agreement, and specific terms and conditions. Signatories, it can be one or more than one parties who are participating in the contract. So they are going to use the digital signature to express their agreement or disagreement. Correct. The next is the subject of agreement, which is an object that can only exist inside the environment of smart contract. Okay, so the subject of the agreement is very important, since that will define your basically what it is related to and whether you agree to it or not. And then the last one is terms and conditions. We all know if else conditions is the way smart contracts are defined. There are This involves a particular set of rule of engagement for both the parties, and it is completely defined mathematically. So it also uses a deep programming language that suits a specific environment. Okay, and as we saw earlier, they are at times readable, but at times they are very difficult to understand. So what we need in order to have these smart contracts created is first, of course, uh, a suitable environment with all the cryptographic algorithms and it kind of allows contracting parties to terminate the deal with cryptographic codes. Okay. A decentralized database, of course, to store the information, and a completely dependable source of digital data. Okay. So all these three things are essential to create the smart contracts. And then how do we fulfill the signature requirement in contract is, I think, the cryptographic keys. So your public key and private key combination of those two forms your digital signature, and that we are going to use as the signature requirement. Usually you sign agreements, right? So in smart contracts, this digital signature plays an important role. Now, interpretation of smart contracts, as we saw earlier, they are at times readable, but at times they are very difficult to understand. So, legal contracts are written in natural language, okay, but smart contracts are written in programming language, and that is why the interpretation of smart contract is really, really challenging. And I mean, the commands are written in straightforward if then if else logic, but then what code means is determined by the context and conventions in the communities, which is not straightforward. Okay, the context might just change according to the, maybe changing over the time or the communities. So even though you are specifying straightforward rules, they can change, the context can change. And some terms in the smart contract may be concerned with details that are left implicit in the natural language formulation. On the other hand, there may be clauses in natural language contract that are not included in smart contract. So both ways it is possible. And that is why the interpretation of smart contract is difficult. So there is a sample framework just I've given, which we called as EVF, evidence, verifiability, and enforceability. So with this is the way we can try to see and enforce the smart contracts. So evidence is includes traceability or auditability. Blockchain proves easy audit trail, right? Because you can definitely audit the historical transaction. Verifiability, which is like immutability. The data cannot be tampered. And then enforceability means peer-to-peer interaction authorized by digital signatures. So smart contracts are continuous real-time tracking and verification, and the data is automated contractual compliance. So the consensus mechanism and real-time updates and all those things are the way which we can afford, which we can um, implement the enforceability of the contracts. So basically, whatever I explained just now, I've just added some notes here. Blockchain. So in verifiability, as I told, blockchain allows stakeholders to assign accountability for various tasks and all. So the same thing that I explained is explained here in the slides, so just for your use, basically. So let's take an example of how we can basically implement the smart contract enforcement. Okay. So this entire example I have again explained here so that you can use this. So assuming that we are dealing with a jurisdiction that acknowledge the enforceability of contracts formed electronically. Okay. So how to enforce them? So the entire thing I have explained, like what happens at each step. So if you see at step 6, there is an obligation of payment of an amount, and in turn supplier has certain performance obligation. So it is likely that there is going to be some exchange between these two parties. Okay. So intention of creating the legal relation, offer and acceptance, and then what is the computer logic that we are going to apply. So that all I have explained here. But usually basically whatever if else conditions that you define, those are the ones that both parties have to agree, sign using the digital signatures, and then they have to abide by those rules. uh, and if at all you are not abiding, there have to be some legal measures established. Okay, so that if we can have some punishments for people who are not following the smart contract that is defined. So how this ecosystem works is, so basically agreements can be of different types. So as we can see here, there are some consortium agreement, governance board. So needed, so as we see, JV consortium agreement is needed between founding members of the establishment. Participating agreement, again those who are participating. Operating rules and platform agreement, users of the platform will be needed to be onboarded by agreeing to the appropriate terms. And then governance board. So all these agreements we will be there in place, and then they, how they interact with each other, and how we basically make people follow it. So allocation of liability, responsibility, all these are achieved using these different types of agreements. Okay, and data privacy, cyber security, cross borders, all these things are addressed. Payments, how they are going to happen, and what kind of rules will be there. So all those things will be included as part of these agreements, and everybody has to abide by these. Okay, so, can code ever be law? This is a big question actually, because smart contracts are defined in coding language. Can this be law? So, definitely they are contracts, and you are signing it using your digital signature. So, they should be held responsible when you are signing that smart contract. But how much it is counted as a valid argument in your legislature is a question, and that totally depends on your legal system. Each country will have its own legislature and legal systems, so it totally depends on them, on how they can basically held people responsible for signing these data. Some judiciaries, I think, I've read it somewhere, Brazil or some countries, they are holding people responsible if even if they have signed these smart contracts digitally. So totally depends on legal boards on how you can, make these smart contracts as a valid document, and argue based on it, and held people responsible for it. Okay, so that is all I wanted to cover today. There were only four topics, and I think we covered it quickly. uh, any questions, anyone? I'm going to share this deck after this meeting, and probably I have this time around for today's session. I have made sure that I'm adding all the notes in the slides, so they are descriptive enough. You can basically go through, and if you have any questions, you can reach out to me. Over to you, ma'am.
Okay, ma'am. Any questions from the participants? No questions, ma'am, I think. If they have any queries, I will get back to you, ma'am.
Yeah, I'll share my email ID and this deck after
Yes,
this.
ma'am, sure. These PPTs also you can share, ma'am. I will make one drive and I will keep it all these things over there.
Yeah, so if we you can give me the drive location, I can
Yeah.
put it there,
Yes, ma'am.
because
Yes, yes.
the deck is heavy enough, and it's
Yes.
difficult for me to put it on mail.
Correct, correct. I will put share the drive link, ma'am. You can put all your data over there. Same drive link I will share with the
Yeah.
participants.
Yes. Yes.
Okay. Okay. Yes. I think we have finished all the units participants. Ma'am has also covered both the units, and all the syllabus we have completed in our this FOW. Thank you so much, Asavri ma'am, for your valuable time. I know you had a busy schedule, but still you have managed to give the two sessions and you have completed your both the units. Thank you so much, Asavri ma'am.
Yeah, thank you so much, all. Thank you.
Yes.
Bye.
Okay, okay, ma'am. Thank you, everyone. Thank you, all the participants, also for listening all the sessions and giving your valuable time for these sessions. I will put the drive link with our in our group, and shortly, by mostly by this weekend or next week, we will share the certificates also. Thank you so much, everyone. Yes, any queries if you have, you can ask. Otherwise, I will end the session. Thank you. Thank you so much.